Seems to be working. Updated the title. Check on touch. This one updated. Yeah, cool. Okay, so yesterday we finished up the tutorial 3. Today we'll continue from tutorial 4 onwards. Uh, there were some slight difficulties, but they have been solved. I was missing this phrase and it was creating build errors. But now everything should be working. Yeah, let me bring this back up and close. Okay, cool. Let's continue with the project.
Navigate to your pipeline header in our pipeline config info struct.
Pipeline header.
We need to explicitly set the values configuring how the different stages of our pipeline work.
Now, if anyone's watching, I highly recommend switching to C-Line instead of Visual Studio. This has been so much better of an experience.
Pipeline input assembly state create info, and we'll call it input assembly.
VK pipeline input assembly state create info. Input assembly info.
Now back in our default pipeline config info function, we set the S type to VK structure type pipeline input assembly state create info.
And this is in which, yeah. Config info. Let's keep the naming consistent. Control Shift F6. Okay, there you go.
Next, we set the topology member to be VK primitive topology triangle list, and then the primitive restart enable value VK false.
Let's bus config info, put input assembly S type, it's VK structure. VK structure. Structure type pipeline input assembly state create info. Okay, just made everything. Okay, false triangles.
Let's go over what these mean. This is the first stage of our pipeline and takes as input a list of vertices and groups them into geometry. In a previous video, I gave an example of a triangle being represented by 6 numbers, but what the input assembler stage sees is a list of numbers broken up into chunks by vertex. Note that we're not just limited to passing in positions per vertex. We can really specify any data we want and choose how we want to interpret it later within the vertex shader. But how does the input assembler know that I wanted these 3 vertices to be a triangle and not say something like a line instead? That's what we specify in the topology. In this case, by default, we will use a triangle list, which means that every 3 vertices are grouped together into a separate triangle. So if we added vertices 4, 5, and 6, we'd have 2 triangles. Another option is a triangle strip, where every additional vertex uses the previous 2 vertices to form the next triangle. This has the benefit of letting us specify more triangles without having to waste memory duplicating vertices, but limits the geometry that we can show to being a connected strip of triangles. This leads us into the next member, primitive restart enable, duplicating vertices, but limits the geometry that we can show to being where every additional vertex uses the previous 2 vertices to form the next triangle. This has the benefit of letting us specify more triangles without having to waste memory duplicating vertices, but limits the geometry that we can show to being a connected strip of triangles. This leads us into the next member, primitive restart enable. By setting this to true, when using a strip variant of topology, we can break up a strip by inserting a special index value into an index buffer. Some other possibilities include point lists, line lists and strips, and triangle fans.
Point list, line list, line strip, triangle list, triangle strip, triangle fan, line list adjacency, patch list.
But for now, we'll stick to just using simple triangle lists. If you want to avoid a bit of upcoming typing, you can grab the rest of the default pipeline config info implementation from the paste bin link in the description below, or from the GitHub repo. First, I'm going to just copy and paste in my entire pipeline config info struct. Each of these
I'll type it out and see what all is there. Let's do this. VK viewport, VK viewport, report. A lot of copying and I want all the values to be the same. Let's copy paste it. Pipeline HPP. Copy paste. I think I'll explain these
members needs to be properly initialized, which we'll do so in our default pipeline config info helper function. So back in our function, let's start with configuring our viewport and our scissor. Viewport describes the
Yes, import assembly info. And get renamed differently. Must have. Import. Alright, put assembly as a P. B, yeah. Save.
Between our pipeline's output and our target image. Back into
Now let's see. Config info dot report dot x equals 0.0. Config info report dot y equals 0.0 f. And config width, height, depth, static, fast, flow. Yes. Okay, it's still not brackets. Okay.
our pipeline's output and our target image.
Min depth, max depth, config info scissor. What is this scissor? Offset equals 0, 0. Then config info scissor dot extend. Go with it. Okay. Hmm. Okay, example from tutorial.
For example, we can render this triangle, but if we change this to render to only the top half of the display, our entire triangle is still rendered, but it is squished into the top half. Min depth and max depth are the depth range for the viewport, and similarly will be used to linearly transform the Z component of GL position. Now, the scissor is kind of like the viewport, but instead of squishing our triangle, it cuts. Any pixels outside of the scissor rectangle will be discarded. So back to our triangle example.
Okay.
If we set the scissor to include only the top half of the screen, only the top half of our triangle would be drawn. We then have to combine our viewport and scissor into a single viewport state create info variable. On some graphics cards, it is possible to use multiple viewports and scissors by enabling a GPU feature, but we'll stick to using just one.
Yeah. Let's sum this up. Config info viewport dot viewport info dot first type was vector structure pipeline create info count equals 1 and config viewport 1 and config scissor. Okay.
Struct type member first. Next, we have a depth clamp enable setting.
Just open this. Yeah. Let's open this on this side. We did this. This one is already there. Now we're doing this. I do think it should be in order, perhaps. So much config info customization info style equals vk structure vk structure pipeline class structure pipeline customization state create info. Config info customization info app enable fonts let's copy paste this master discard equals vk files dot polygon node false polygon full VK polygon mode full. Say Control V, battle line width, false 1 0 F, Control V, and call mode false. VK VK call mode none. Control V, front face, false VK, front face clockwise. Control V, dot depth, bias, enable equals VK, false, VK, false. Oh, I wonder whether like VK false and whatever doesn't get the intelligence properly. Okay, that bias constant factor, that bias clamp, and slope factor. We're setting all of that to 0. Yeah.
What this setting does is it forces the Z component of GL position to be between 0 and 1. Values less than 0 are clamped to 0, and values greater than 1 are clamped to 1. Usually we don't want this to be true, because if a value is less than 0, it is kind of like something being behind the camera. And when Z is greater than 1, it's like being too far away to see. So keep this false for now. Note that using this requires enabling a GPU feature. I'm going to mostly just focus on describing settings that are relevant to us now, or in the near future. If there's a member variable that you'd like to know about in more detail, it is easy to look up a term in the official documentation, and I recommend starting to do so, as getting used to reading the documentation will be very helpful in the long run. So rasterizer discard enable discards all primitives before rasterization, so you'd only ever use this in situations where you only want to use the first few stages of the graphics pipeline. Polygon mode is for when drawing triangles. Do we want to draw just the corners, the edges, or the triangle filled in? Line width is pretty self-explanatory. Okay, now cull mode. This is something that matters. We can optionally discard triangles based on their apparent facing, also known as winding order. This is determined by the order of the 3 vertices making up the triangle, as well as their apparent order on screen. For example, which face we are looking at, walk around the triangle in the order we specified our vertices. If we provided vertex 0, vertex 1, and then vertex 2, then we would be seeing the clockwise face. By swapping the order we provide any 2 of the 3 vertices, we can swap the winding order to the opposite direction. Additionally, the face we're looking at depends on our point of view. Without changing the order of the vertices, if we were to change our point of view to look at the other side, it has the opposite winding order. Therefore, we can use this property to uniquely identify which side of a triangle we are seeing. We need to specify whether we want to use the clockwise direction or the counterclockwise direction as the front face, and then if we want to cull the front or back faces. For now, we will use none as our default so that we don't accidentally cull our first triangle. Backface culling can result in some pretty big performance benefits, and is something we'll come back to soon. Lastly, depth bias can be used to alter depth values by adding a constant value or by a factor of the fragment's slope. We won't use this for a while, so leave this disabled. Multi-sampling is a topic we'll cover in a future video, but relates to how the rasterizer handles the edges of geometry.
This guy's just copy pasting the code from your then CPP. Config info, get the section by here. Okay. Let's copy all of this. Okay. The lower stuff. Yeah, video, no. Yeah, let's continue with the video.
Without multi-sampling enabled, a fragment is considered either completely in or completely out of a triangle based on where the pixel's center is. But this can result in some other
And this is just anti-aliasing
jigging.
settings.
MSA is a method where multiple samples are taken along the edges of geometry to better approximate how much of the fragment is contained by the triangle. And then based on this, shading the pixel
Hmm. But we had some. It's kind of odd. I'll just do it so that I don't forget. And yeah, there's some settings. Oh, rasterization settings. Like this just people settings. Hmm. Yeah, good for now.
amount. Color blending controls how we combine colors in our frame buffer. If we have two triangles overlapping, then our fragment shader will return multiple colors for some pixels in our frame buffer. Here, we can optionally enable color blending and set the values determining how we mix the current output with the color value already in the frame buffer, if any. Mixing occurs based on something like this. We'll come back to this in more detail once we start working with transparency. And finally, we have depth testing. So a depth is based on optionally enable color triangle, and then based on this, shading the pixel by a variable amount. Color blending controls how we combine colors in our frame buffer. If we have two triangles overlapping, then our fragment shader will return multiple colors for some pixels in our frame buffer. Here, we can optionally enable color blending and set the values determining how we mix the current output with the color value already in the frame buffer, if any. Mixing occurs based on something like this. We'll come back to this in more detail once we start working with transparency. And finally, we have depth testing. So a depth buffer is an additional attachment to our frame buffer that stores a value for every pixel just
depth buffer, color buffer, depth buffer settings, and then color buffer settings. Setup and then no settings. Yeah.
Previously, I've compared depth values to being like the layers in an image editing program, but this analogy isn't exactly true. A depth buffer doesn't keep track of individual layers, but only the depth value to whatever fragment is currently on top for each pixel. For example, let's say so far we have rendered some mountains and our color buffer looks like this. Then the matching depth buffer would look something like this, where light shades are far away, its depth against the current values in the depth is 8, then it is less than the sky's pipeline has not yet been set, the pipeline layout, and the render pass. That is it for our default pipeline configuration. But
Save.
back into our struct, we have two more values that have not yet been set, the pipeline layout and the render pass. We don't provide any default for these members, and we'll set them outside of the function. Okay, so now it's time to complete our create graphics pipeline function. Let's replace these lines outputting our code size, and instead
Bring this back. This wants something to offset it a bit. And then all patterns, CPPI. Okay, yeah.
initialize our shader modules. Call create shader module and pass it in our vertex code and
Content one. Okay, create shader module. comment that out.
To our vert shader module. Then copy and paste to do the same for our fragment shader. Now we need to set just a couple more create infos for the vertex shader stage and fragment shader stage. So create a new local variable of type vk pipeline.
VK pipeline shadow stage 8 and 4. Shadow stages. Okay, let's go to this. Shadow stages 0. No testing. False. VK structure. Shadow stage structure. Shadows stage 8 and shadow stages stages. Let's copy paste this. Okay, stage. Also we can stage vertex bit. Dot module. Also shader module. And name equal name. And flags or 0. I'll mock you. Thanks for joining the stream. I know this is a bit technical stuff, but glad you could join. Flag 0. Shadow stages 0 be next. The next equals null pointer. The specialization equals null pointer as well. So I'll delete that. Okay, everything's copied. Cool. Uh, Hi guys. Yeah, I'm creating a render. This is just to like learn Vulkan. So I'm following along with
For variable to equal
this tutorial. That I found it's a bit old. I would like it if there was something more recent. But for now, this is the best tutorial series I could find. So yeah, this is what I'm doing. If you want, I can share the playlist. Let's see. Is it? Yeah. I should probably pin the playlist. Let's see. Not sure. Tutorial playlist. I wonder, can YouTube chart do pins in this? Okay, it's been pinned on Twitch. Let's see if YouTube does spinning. Let's go to YouTube chart. Should be able to pin it. See, pin message. Okay, cool. Uh, yeah, Jumpy Mouse. Vulkan does have very limited ones. Even the main website. One sec. Is that not? Split H. Yeah. Okay. Now it's switching correctly. Yeah. Even for the main Vulkan tutorial, this is like super old. If you go to the comments here, you can tell. Like they didn't use CMake for any of this. They use Visual Studio. And I think it's what the 2017 version. So it's nearly like 10 years old. In another 2 years, it'll be 10 years old. So you can just see how old all of this is. There was a comment section somewhere. Is it under overview? Oh, well, there was one somewhere because I remember getting a lot of help from that. Setting up that development environment. Am I just missing something? Was it perhaps like another page? Let me see. Maybe it was on the like Chronos website. Let's say it was.
Hello, and welcome to episode 1 of this tutorial series, an introduction to computer
Yeah. Vulkan tutorial development environment. Hmm. I remember I was on a page that had like a login and stuff to add comments. Is it under like FAQ? Hmm. See, Vulkan CMake setup. Was it on this? No. Setting up Vulkan. Was this somewhere? I don't think it will be this hard to find again. Oh. Oh, but like if you want the CMake file, I have it on my GitHub. Or you can just take a screenshot of this. So it will automatically get the GLFW and GLM file. You just have to install the Vulkan installer and get that set up. So yeah, I'm surprised I still can't find it. That's strange. Controller CMake. Hmm. Jumping ass. No, I don't code now. Did you used to code? Were you like into these render stuff? Or were you perhaps like doing game dev?
Frag shader module.
Let's go. Okay. That. And so we frag shader module. Main null pointer, everything else is
Create a
fine.
new local variable of type vk pipeline state create info called vertex input info. This struct is used to describe how we interpret our vertex buffer data that is the initial input into our graphics pipeline. We need
Mm.
to set its S type to vk structure type pipeline vertex input state create info.
Okay, so is here how much more easier this would be in OpenGL? Because I've heard it's easier, but also outdated. Do you write render before using DirectX or OpenGL? Or I'm not sure what you mean by the question because DirectX and OpenGL are the rendering frameworks, I guess, like Vulkan. So you can either do it in Vulkan or OpenGL or DirectX, is from my current understanding. You could have a whole other program where, like, let's say for a game engine, you want to be able to swap between DirectX, Vulkan, and others. Then you might implement things differently. But for now, I'm just trying to learn Vulkan and like refresh my C++ skills because I've not used it since I was like in grade 12. So yeah, so this renderer will be in Vulkan only. Maybe in the future I'll consider trying out DirectX and some other things, but for now just to learn what the rendering process is like. DirectX I might consider doing in the future. OpenGL is basically super outdated now, so I don't think I'll be going that learning OpenGL unless required for a job or something. Hmm. Are you perhaps curious about what the code would look like for OpenGL or DirectX? There was some. OpenGL has quite a lot of tutorials. Vulkan is only one that's messy. DirectX actually I haven't checked. Let's see. DirectX tutorial. This looks super outdated. Let's see what date was it. As using V for Vendetta from 2020. That's when it was last updated. Okay. DirectX, what is DirectX tutorial? Okay, this one is a course. Hmm. This one, okay, it's pretty recent. Let me put this up on the big screen. Okay. Project setup, window creation, window message, connecting to hardware, debugging. Um, no.
All right.
Let's see.
Hello, everyone.
Started playing in the background. So let's see. The first DirectX 12 application. Yeah, this is quite a lot. Day and night circle. Wow. Blend and stencil, creating transform matrices. Simple HSL room shading. Interesting. Maybe I'll consider this afterwards, but for now, and to finish the Vulkan project. Can keep this down here. Yeah, it's researched. Yeah, cool. Yeah, the current version is 12, but from what I've seen often, it's supposed to bring like more performance and like give you better like low level features. But all the softwares I've seen implemented, it just ends up being more laggy. Often the previous version 11, even though it might not look as good, like it doesn't do ray tracing as well, but it does have like better performance in general. So I'll have to see, because at a lot of the work I was doing for game dev stuff, we would often default to Direct 12, Direct 11, I mean, just because we would get more performance for these like simple scenes that didn't require like ray tracing or something. If you're doing Unreal Engine type of quality games, then Direct Direct 12 is required. But yeah, let's continue with this. Where was I? Got lost.
Then set the vertex.
Okay, he was making this. Yeah. Okay, pipeline vortex. Input state create info. Vortex create info. Brackets. Vortex input. Wait, this is wrong. This should be input info as this, and this is run. I think I caught this now only. VK pipeline vortex input state. Create info. Yeah. Now it's correct. Input info. What S type? How do I keep mistyping that? Calls VK structure. Oh, VK structure. Okay, so yeah, autocomplete. Give a pretty good suggestion. Structure type pipeline vertex input create. Okay,
description and vertex binding
seems correct.
description counts to 0, since for now we've hard-coded vertex data directly into the shader and therefore aren't supplying any data as of yet. Also set
Okay,
p vertex attribute descriptions and p vertex binding descriptions to null pointers. And now finally,
yeah, right. Added vertex binding and vertex attribute. I'll just copy the locations.
graph
Right. Okay. Here we go. Now back on the screen. I have to figure out what is messing up the switching for this, but should be fine now. Where was it? Yeah. No shift. Okay. Attribute binding. Attribute binding. Okay.
create info, which will use all of this configuration we just went through to create our actual graphics pipeline object. Make a new local variable pipeline info and set its S type to VK structure type graphics pipeline create info. Next,
Hmm. This one has like so much setup. It's priced. VK. VK. Oh, caps lock is still on. VK graphics pipeline create info. Yeah. Pipeline info. Hmm. I wish Vulkan supported some like more languages that were a bit higher level instead of C++. Getting these going from like C# where you don't require header files to C++ where this is just mandatory has been quite annoying because it just adds confusion. Even if you want to do a simple thing, you need two files each time. But I guess I'll have to get used to that. Where do the farmer? Are we winning? Oh, seems like it.
member variable stage count
Uh, yeah. We're currently in part 4 of this tutorial series. And so far, everything has worked fine. We'll continue to see if that's the case. Let's see, pipeline info.s type vk structure structure type graphics pipeline create info. Yeah, looks correct.
to 2 and p stages to our shader stages array. The stage count is to specify how many programmable stages our pipeline will use. So in our case, for now, we just have the
Stage count, shader
vertex and fragment
stages,
shaders. Next, we
and
need to wire up
vertex
our
input
pipeline
flow.
create info to our config info. This is a bit tedious, but because we've separated our configuration from our pipeline creation, we should only have to do this once now, and then can use this code whenever we want to create different pipelines in the future. So go through and
So where do the farmer? How's your day going? Background. P input. Roles. And config info. Not input assembly info. Oh,
and for the color blend state, use config info.colorblend info, not the color blend attachment.
color blend rasterization state. It's added a bunch more stuff. Let's go back.
Config info, viewport info, not config info.viewport.
And we will add this pipeline. Let us copy this. Yes. Okay. After we using it a lot. Viewport state equals and config info dot viewport info the rasterization state else and config rasterization info.
Blend state, use config info.colorblend info, not the color blend attachment. And for p dynamic state, just specify a null
It
pointer.
is just
This is an optional
setting
setting
all of
used to
them.
configure some pipeline functionality, such as line width or the viewport dynamically, without
What's this one? From this. Figure that out. Right now I'm just learning Vulkan for the sake of learning. Hopefully it like helps on the resume and stuff. Just in case I want to switch to normal software engineering type of projects. Because right now everything is for game dev. So it's like Unity, Unreal, then like there's a little bit of Godot, and then there's like Houdini, Blender. I don't have much traditional work, so I was hoping to like one learn Vulkan. It'll probably be helpful in game dev to know how renders are made, and also it might help out in my resume since I'm currently job hunting right now. So I get some freelance work, but really freelance isn't for me. It's too irregular. Like my last freelance work, I had to wait like a month before I finally got paid, and I had to keep nagging the guy. So honestly, it's not for me. There's a lot of like networking and like marketing and sales stuff as well, which I can do, but I don't like doing it. I'd rather just like get at a stable job and just be like coding stuff. So yeah, right now this is just to learn. I wouldn't exactly call this fun, but it is interesting. Tedious, but interesting. Where were we? We are at rasterization. Next is color blend. P color blend. Color blend info. Say pipeline info dot depth. P and config info that stencil info. Let's see, p dynamic state equal null pointer.
Recreate the pipeline. We'll probably use this at some point in the future. Finally, also pass through our pipeline layout, render pass, and subpass index to our create info. We haven't configured these values yet, so when we run our program, we'll get an error. We also have two more parameters, base pipeline.
Search. This is all like one function. This is too many lines for one function. But
handle
we'll
and base
follow along
pipeline
for now.
index, which I only mention now for completeness. These can be used when trying to optimize performance.
See pipeline and layout, render pass, subpass. Okay, these are fine. Pipeline info dot base pipeline index equals -1. And pipeline info dot base pipeline handle equals vk null handle.
Pipeline by deriving from
Let's
an existing
continue.
one, but we're not going to worry about this for now. And now in an if statement called vk-create-graphics pipelines, we pass in our device, a null handle for our pipeline cache. This is another possible performance option. Next for our pipeline cache.
Do we even make the triangle on this one? Disappear.
Just one, and then
Maybe. Either for me, I'll look in this Vulkan code and it's not fun for me. Seems very hard, but I'm not a coder. Time to play with Unreal. But it's more Hello World project. Yeah, this is very much in the advanced segment of like coding things. Like, I remember, I don't know if you know this YouTuber, uh, it's in 2-minute papers, where he like just goes over like various research papers. 2-minute papers. He has like a master's course, like playlist on this. So like this is very advanced stuff. It was somewhere here. Yeah. He has an entire playlist from his course on just like ray tracing stuff. The Unreal Engine, it's much easier to get into than all of this. Obviously, because it is made to be much easier. But like if you just want to like get your hands a bit dirty with game dev stuff, I would suggest checking out Godot. It's a lot more user friendly, and also it's a lot more beginner friendly as well. Whereas with Unreal, you have like 30 gigabytes, I think, just to install the software, whereas Godot is much smaller. And I think in another 5 years, it will become more and more mainstream. It has good competition, unlike Blender. Blender only had like Maya and Houdini, but Godot has Unity and Unreal as competition, but I think it will still do well in the next 4 5 years. It's already catching up quite well. Yeah, so if I click download, does it show how big the file size is? Yeah. Okay, it's only like 73 megabytes for Godot. So It's pretty quick. You can also do it on your phone, by the way. They have an Android app version. So it's quite accessible. I think they also have an iPad version now. So it's really there on any platform. You can also just do it directly in the browser. So you don't even have to install anything for that version. Go to browser. Go to engine web editor. Start. Loading. Have to reload some. Try this, for example. Yeah, shows for download. Reload project zip. That loading. Okay, it's here. Can create new project. Create. Takes a while to load, but like if you were doing this on your own system, it would be faster. So yeah, you can just use it directly in the browser. I'll continue with mine, but I would definitely suggest checking it out. Jumpy mouse. Also Vulkan in 13. Weight again is auto modded. I have 140 cat. That was to prevent like really long messages, where like it just takes a long time to read, and like also to prevent some spam. 140 characters, I think, was slightly more than Twitter word limit. So yeah, the auto mod was also to prevent like spam and like bots and things, because every now and then I get what do you call it, like bot raids or whatever. So that's why I have some auto mod stuff. I've kept it quite strict, uh, but yeah, it hasn't been too much of an issue. Wait, held a message for using private blocked. Wait, why did happening get? Why is it not switching? Yeah, okay, happening got back. Yeah, I'm not sure. Hmm. I'll have to see which word is getting detected. So my point is my brain is more work with schematics like blueprints. Yeah, blueprints is quite easy. I think Godot has like a node thing. It used to be official, now they've like made it a separate plugin, but you can check that out. And Godot visual scripting, that's what it was called. Getting started with visual scripting here. This is in 3.5. There's a way to change. 4.5? Is that the latest version? Let's say good. Which is the version I don't? 4.5. Yeah. It seems if you get 3.5, it will have it. But yeah, if you want to use blueprints, then yeah, they stopped working on visual scripting on Godot. Yeah, it's now like a separate plugin. So yeah, if you do like the blueprints and that works for you, then yeah, Unreal Engine is your best bet. Just be careful, it is very performance heavy. So if you have a decent laptop, go for it. Otherwise, it can be quite laggy. Back in college, I had to like teach students Unreal Engine, and that was one of the biggest issues with it, was just the performance. So yeah, just check if it runs properly. Let's see, you could do visual scripting plugin. Oh, you're not disturbing. It's all good. It's nice to have someone to talk to while I'm doing all this. Plus, these are like just fun rabbit holes to go down. It's not like I'm on like a certain schedule or anything. The timeline I've given is kind of suggestions. So yeah, let's see. Yeah, this is one plugin that's for 4.3. It's called Orchestrator now. Hmm. Yeah, they seem to have quite a big variety of them. Last update was in May or August, depending on how they've numbered things. Yeah, this is nodes as well. But yeah, I'd say stick with Unreal if you like the blueprint version of things. Yeah, well, this isn't needed. This isn't needed. It is this closed. This can be closed. I will definitely look for that comment section. I just want to find it again now. But let's at least finish this part for
And a pointer
tutorial.
to our pipeline info. We're not using any allocation callbacks yet, so just a null pointer here, and for the last
And yeah, let's save. Yeah. But I move this up here.
pointer to our graphics pipeline.
Mm.
Check that this is not equal to VK6.
Is not VK success. For such a long line. Yeah, VK graphics pipeline, LV device, VK null handle, then one pipeline info, null pointer, graphics pipeline, not VK success, through error.
Otherwise, throw a runtime error that a graphics pipeline has failed to be created successfully. And before we forget, let's scroll up to underneath the constructor to implement a destructor to clean up our Vulkan objects.
Okay, I have to create a destructor as well. Let's see here.
Use VK destroy shader module to clean up both our vertex and fragment shader modules.
Okay. Let's see, LV pipeline. No squiggly. I wonder what this is called. VK destroy shader model. Shader model. All device. Not device. Or shader
and then
null
VK destroy
pointer.
pipeline on our Vulkan graphics.
Or shader module null pointer. Okay, VK destroy pipeline. Graphics pipeline null pointer. Okay.
Lastly, in our pipeline header, remove the empty body for our destructor. So at this point, your code should compile, but when I try running it, it crashes because I haven't yet provided a pipeline layout or a render path. But this is a good example of how the validation layers our device file set up for us can help us debug our code. If you look at the first validation layer message, it says vk create graphics pipelines, required parameter p create infos dot layout specified as vk null handle. So we have the function call where the error occurred, in this case vk create graphics pipelines, and it tells us that we've passed a null value for our layout parameter. Just
Okay, let's set as an array.
we have the function info, and then vk
Okay, we open was arrow. Has already been defined or declared. Let's see. Let's log it in that. Yes.
line on our Vulkan graphics pipeline handle.
I'm missing something.
Lastly, in our pipeline header, remove the empty body for our destructor.
Yeah. That's what we are missing.
So at this point, your code shows the empty body for our destructor.
Yeah. Okay. Save. Okay, now it's fixed.
At this point, your code should compile, but when I try running it, it crashes because I haven't yet provided a pipeline layout or a render path. But this is a good example of how the validation layers our device.
Okay, let's run it and see what messages we get. Okay, crashed as he said it would. Okay, validation, device count, physical device. every here.
File set up for
So
us can help us debug our code. If you look at the first validation layer message, it says vk create graphics pipelines required parameter p create infos dot layouts.
create graphic pipeline
Specified as vk null handle. So we have the function call where the error occurred, in this case vk create graphics pipelines, and it tells us that we've passed a null value for our layout parameter. Just below we have a similar message saying we did the same, but in this case
render process now. Step. Render pass must not be that. But they change how they show things.
for our render path. But then below that is a message I didn't expect. So let's look into what
Rasterization. Last two lines. Null and only one area has null on.
it says. If our rasterizer discard enable is false, multi-sample state must not be null. So I do remember setting up our multi-sample state create info in our pipeline config, but let's take a look back in our create graphics pipeline function. And yep, right here, I forgot to connect my multi-sample state info. So just below my rasterization state, I'll add a line for my multi-sample.
Yeah. Is in CPP dynamic state. Rasterization info. Multi-sample info.
Now, if we try building and running again, we can see that the validation layer message has gone.
Save. Let's run this. Render process now, a dynamic rendering feature was not enabled.
These requirements just a little more explicit by first including c-assert at the top of our file. And then at the start of our create graphic
include c-assert.
pipeline function, add an assertion to check that our pipeline
Is assert config info at pipeline layer not equal to
in the pipeline config info is not a null handle. And similarly, let's copy and paste this and do the same for
false vk null handle. and cannot create graphics pipeline, no pipeline layout provided, and config info.
Now, if we build and run, it's unambiguous that we haven't properly set up our config info.
Okay, we're doing another sort. Node and promise certain here. And here as well.
Because we're missing a pipeline layout and a render pass. And that's where we'll leave things for today. In the very next video, we will have...
Yeah, let's build everything. Okay, let's finish building. Let's run it. Yeah, let's see. Okay, we're getting the same error, which is good.
drawn our first triangle, and from then on our results will be much more visual. We will continue to work with pipelines a lot over the course of this video series, which will help reinforce the operations of each stage that were introduced today. Many of the parts we only briefly covered today will get their own dedicated videos, diving into their functionality in more detail in order to get new visual results. Anyway, thanks for watching. If you're finding these tutorials helpful, please like and subscribe.
Let's check the comments and see if there's anything. Yeah, there's some minor fix.
Single viewport state create info variable. On some graphics cards, it is possible to use multiple viewports.
Okay, we'll go over that in the next video. Okay, let's go on to the next one.
The swap chain is a series of frame buffers used to display images to our window. In previous videos, I've said how our graphics...
Let's save all of this, upload this all together. Finish tutorial. Button push. Push. Cool.
to a target frame buffer, and how a frame buffer can have different attachments, such as color buffers or a depth buffer. Now, the swap chain also uses these frame buffer objects, but to read from the color attachment to then display to our window surface. Any modern operating system will typically use at least the swap chain. The swap chain is a series of frame buffers used to display images to our window. In previous videos, I've said how our graphics pipeline outputs to a target frame buffer, and how a frame buffer can have different attachments, such as color buffers or a depth buffer. Now, the swap chain also uses these frame buffer objects, but to read from the color attachment to then display to our window surface. Any modern operating system will typically use at least 2 buffers at once,
Mm.
and the buffer being rendered to is designated the back. Sync or vsync is the moment at which the display begins drawing the new image and is tied to our display's refresh rate. So for example, if your display's refresh rate is 60 Hz, that means 60 times per second or every 16.6 milliseconds, the vsync occurs and our front and back buffers are swapped. It's possible to ignore the synchronization. In many games, this is done by disabling vsync in the graphical settings, in which case you may observe tearing. Tearing is when our display shows information from multiple frames in a single screen draw. Note that not only do we have multiple frame buffers, but each frame buffer also requires unique attachments. This isn't always true. Depending on our usage, we can get away with sharing certain attachments like the depth buffer some of the time, since you next vsync and frame buffer swap before starting to work on the subsequent frame. If we had a second back buffer, we could start working on the next frame immediately. This is known as triple buffering. The main downside is that extra memory is required for storing the additional image. The main upside occurs in cases where rendering a
Are we
frame
going to
can't
be
keep up
doing
with the
triple
refresh rate of
buffering
the
now?
display. With double buffering, even if a frame just misses working again, to a user on. If you've worked with OpenGL or other graphics APIs before, triple buffering is probably not something you've had to deal with. It's usually handled automatically behind the scenes, but like with most things in Vulkan, we need to be explicit about it. Of course, all of this is a bit of a simplification, and there are exceptions to this. You may have heard of adaptive sync or G-sync, which changes the display's behavior so it doesn't have to wait the entire update period before refreshing. Also, all of this depends on the type of present mode our swap chain is using. We'll discuss this more in a bit, but for now the key takeaways are: 1. We will have multiple frame buffers, likely 2 or 3. And 2. Each frame we ask the swap chain to tell us
Yes. What shows which device gets used for Vulkan? I'll just take a quick break and come back. Let's see. Hey guys, I'm back. Let me just make sure this updates correctly on Twitch. I fixed the moderation issue. Uh, like the middle of the word happening, it was getting detected as a potentially bad word, which is why the auto mod was detecting it. That has now been fixed. So let's continue. We here we go. Yeah. Okay, let's download this. Download, download. Okay. Mm, let's add this. Again, I can Vulkan stuff, Vulkan loader. Shadows, this can go over here. And this can go under source. Okay, these have been added. Rename LVE. Next, let's rename this. LVE. Hmm. Control Shift R. Engine. Replace with LVE. LVE. What all changed? Control Shift R. Engine with LVE. Replace. Oh, Hmm. Yeah, that's just a spelling error. Always option. Hmm. Function. Rename. Oh, case. Resolve an error. No errors. Yeah. Also warnings, but no errors. Okay, and I'll just rebuild it. Okay, done.
Now navigate to your window header file and add a getter that's going to return a vk extent 2D.
Let's see. LV window. HTTP. We need to use these other things. Yeah, yeah.
Get extent and return our width and height. So if you check out the type here, extent
Hmm. Okay, sure. It's VK extent to real. Get extent. Return with height.
struct of an unsigned width and height. Out the type here.
Non-constant.
Extent is just a struct of an unsigned width and height. So really,
Go to definition. Let's say go to declaration. Yeah, it's event.
we should explicitly cast these int values. So add a static cast uint32 type
Okay,
around width
let's
as
do
well
it.
as around the height.
Alt enter. Context. No. Static cast un 32t. Brackets. Yeah,
Unfortunately, last week I made a mistake. If you open your pipeline header file, you may be able
pipeline header file.
the problem with the pipeline config info struct. So let's fix this quickly. Start by deleting the vk pipeline viewport state create info. Then open your pipeline implementation file. In our default pipeline config info function, the problem becomes more obvious. I had made it so that the viewport info has members that point to our viewport and scissor, which are stored in the same struct. This is typically something you want to avoid doing. If we create a copy of our pipeline config info, the p viewports and p scissor fields will point to the previous struct viewport and scissor, which may then be deallocated. Definitely not what I intended in this case. Now, depending on your compiler, you may or not have run into this, because some compilers will optimize away the copy of this return in a process known as copy elision. So copy and remove these 5 lines, and then paste them above our pipeline create info in the create graphics pipeline function.
Report info need deleted. Pipeline CPP.
Create a new local
Config info.
pipeline viewport state create info called viewport info. And don't forget these 2 braces at the end. These braces have
Was he putting it? Yeah, in between these two. VK pipeline. Viewport. VK pipeline. Viewport. State create info. Viewport info.
value initializing all of the struct members. So in this case, we are relying on the braces to set p next pointer and flags to equal 0. Remove the config info qualifier before each line and update the p viewport state to point to the local viewport info variable we just created. In our swap chain class, we have a function blend. These braces have the effect of value initializing all of the struct members. So in this case, we are relying on the braces to set p next to be a null pointer and flags to equal 0. Remove the config info qualifier before each line and update the p viewport state to point to the local viewport info variable we just created.
Okay.
In our swap chain class, we have a function called choose swap present mode. Depending on your graphics device, I've set things up to choose the mailbox present mode by default, and then vsync as the fallback. The present mode configures how our swap chain handles synchronization with our display. We can check the
Let's open the device CPP. Create instance, pick physical device. Find usages. Declaration. Event device count as the total number of devices. Enumerate device data. We can get physical device. of device local variable explicit device now we'll go to the next one. Let's see. Choose the second device. Of the suitable device. As the object get the index automatic. Find all devices. Use normal for loop. Use normal for loop. Select the second device. Let's see if this works. Let's run it. Let's see. Okay, nice. Got set correctly. And let's see, can this be condensed simple? Can be condensed or simplified. No, that's too messy. Hmm. Okay, so now this is good enough. Let's continue with
Description of the
this.
possible present modes. The only present mode guaranteed to be supported is FIFO.
Swap chain,
Check that the available present modes vector contains your choice.
swap chain mode. Apply an XML submit command buffer. Create swap chain. Create render pass from buffers. That's right at that. Okay,
Returning it. So the FIFO present mode is what I discussed at the start of this video. This is where the swap chain synchronizes with the vsync of our display to prevent tearing. So what's the difference between FIFO and mailbox? Well, when using FIFO, if our GPU can process images really fast, even if we're triple buffering, both our back buffers can be written to, and then our GPU will idle until the next refresh cycle where our swap chain swaps the images. But when using the mailbox present mode, the GPU never idles, and instead will discard and overwrite the older back buffer. When the display is ready to refresh, the swap chain will take whichever back buffer is completed with the most recent image. The advantage of this is that the frame presented to your display is fresher in terms of it will be updated with the latest user input, so input latency can be lower versus when using FIFO. However, because our GPU never idles, unless our application provides some additional manner of throttling, this can result in very high power consumption. So this is something you typically not want to use for mobile devices. So if you'd prefer to always use vsync, then you can comment out these lines like I have already done just below. The immediate present mode does not perform any synchronization with the refresh cycle of the display when updating the current image. This may result in visible tearing, as well as a high CPU and GPU usage. I usually only use this when I want to get an indication of performance and maximum FPS, since my device does not support the mailbox present mode. Now in our first app header, let's include our swap chain, and then below our device, we create a new LV.
Legacy, recent. Mailbox recent. And then no auto format. What am I clicking on? Code, inspect, analyze, code cleanup, folding, rearrange code, reformat. Control A. New format file. Do not keep blanks. Is that done? Did not. Let's
swap chain variable, LVE swap chain, with our the first parameter and our window.getExtent as the second. Don't forget that order here matters, and that variables are initialized from top to bottom and then destroyed in the reverse order.
Is there no like code? No. No.
And then below our mode, performance and maximum FPS.
Faithful, fast and fast out, always supported. Yeah, this is in the legacy. Immediate noise. Move fast up.
Device does not support the mailbox present mode. Now in our first app header, let's include our swap chain, and then below our device we
Now should include LVE swap chain.
create a new LVE swap chain variable, LVE swap chain, with our device as the first parameter and our window.
LVE device, LVE.
So if you build and run your code, in your console you should find an additional message saying what the selected present mode is just before the failed assertion we added in the
It's not it. Present mode mailbox. Okay, cool.
previous video when initializing our pipeline. Okay, back to coding. In the first app header, add an include for memory, and now we're going to make the pipeline object be a unique pointer instead. So let's get rid of our old pipeline.
Now should include memory.
And declare a new std unique angle brackets LVE pipeline, and I'll name it LVE pipeline. Also, this is a smart pointer. If you're unfamiliar with these, I strongly recommend doing a bit of reading on this topic. Learn
Okay, pipeline. Pipeline. std vector vk buffer command buffer.
To add include vector in our list of includes at the top.
Layout void create
And finally, void create command buffer.
void
as well.
void create pipeline void of
Next, add a declaration for a constructor and destructor for first app. And finally, because our app is now managing Vulkan objects for our pipeline layout and command buffers, we
first
our copy constructors. I always forget how these go, so I'm just going to copy them from window and paste them in, and then update window to first app.
window first save.
Start with implementing our create pipeline layout function. Grab the function signature and paste it in. Add your class name, scope, and then create a VK pipeline layout. Create a variable called pipeline layout info. Just like we did in the previous video, we need to set the members of this struct. So first set
Void first create pipeline VK pipeline pipeline link create info create pipeline layout info.
structure type pipeline layout create info. For now, we just want to create an empty layout. So let's set this
Pipeline layout info artist type.
set layout count member to equal 0 and p set layouts to equal a null pointer. A pipeline set layout is used to pass data other than our vertex data to our vertex and fragment shaders. This can include textures and uniform.
Pipeline layout set layout for 0 and set layouts null pointer
objects, which will all be covered soon. Next, set push constant range count to 0 and p push constant ranges to a null pointer. Push constants are a way to very efficiently send a small amount of data to our shader programs, and I think we will get to them in about tutorial 8 or so. Then in an if statement called vk_create_pipeline_layout, with our device.device, a pointer to our pipeline layout info, a null pointer vk success, and in such a case,
If we can create pipeline layout or we device device and pipeline layout info null pointer and pipeline layout. Cabbage. That's here we go.
a runtime error failed to create.
Not equal became. Thanks for the wishes, Weirdo the farmer. Hopefully I can see you again tomorrow. Good luck to you as well. And VK success. Throw arrow.
Pipeline layout. At the start of the first app implementation, also add an include for std except.
Function include std except.
Next, let's implement the create pipeline function. Grab the function signature from the header file and paste it in. Then add the first
Another function now. Create pipeline.
We're going to start by creating a pipeline config. So auto pipeline config equals lv
Auto pipeline config equal the pipeline default pipeline config and the swap chain not that and the swap chain dot height not at all.
It's important to use the swap chain's width and height as it doesn't necessarily match the windows. On high pixel density displays, such as Apple's Retina displays, the window measured in screen coordinates is smaller than the number of pixels the window contains. And we will set the render pass member of config info to our lve swap chain.getRenderPass.
Okay. Pipeline config render pass lve swap chain not get render pass.
Lumped creating a default render pass in with the swap chain code. This is something we will eventually pull out after we cover render passes in more detail. For now, all that is really necessary to know is that a render pass describes the structure and format of our frame buffer objects and their attachments. For example, in this basic setup, in attachment location 0, we will have a color buffer, and in location 1 will be a depth buffer. So it may help to think of a render pass as a blueprint that tells a graphics pipeline object what layout to expect for the output frame buffer. That way, when it's time to actually render, our graphics pipeline is already prepared to output to a frame buffer, as long as the passed in frame buffer object is set up in a way that is compatible with what we specified in the render pass. For more complicated render passes, for example, a sequence of post-processing effects, multiple subpasses can be grouped together into a single render pass. Set the pipeline layout member of the config info to the
Oh, it's already 5 o'clock. Let's
pipeline layout
do
member
one
variable.
more tutorial at least.
So let's
And
finish
get the
creating our pipeline by
triangle.
setting the pipeline member variable equal to std make unique LVE pipeline. Then for the first argument, LVE device, next the vertex path at shaders slash simple underscore shader
Okay,
dot spv, and then the
I haven't
fragment shader,
finished typing.
shaders slash simple
Pipeline config dot pipeline layout equals pipeline layout. LVE pipeline. std make unique. And stop. Okay, LVE device. Shaders. Simple vote. And what was then the first CPP? First PHP. Is it then a main? Window device. Which one has not this? Yeah. Flash the phone, should have okay, it's then the HPPP version. It's not getting used here anymore. Let's see. I go again. Probably shader path. Shader path goes all the way to shaders. Simple. No, shader. But what? No, SPV. Let's copy this, paste it, and yeah. No, I don't.
.frag.spv, and finally the pipeline config. In our constructor, let's add calls to first create pipeline layout, then
first first yeah, create pipeline layout, create command buffer.
line, and then create command buffers. In the destructor, make sure to destroy the pipeline layout with vk destroy pipeline
We can destroy
device.device, pipeline layout, and null pointer. If we add an empty implementation for the create command buffers and draw frame function, then our code should now compile. And since we've now provided a pipeline layout and a render path,
first step CPP word create first step create command buffers draw frame
are assertions that should now pass, and creating our graphics pipeline will
must be outside. Yeah.
So let's build and run our code. And you should now have an empty window again, and in your console, the previous assertion messages should now have disappeared.
Okay, let's start. Okay, how's the spelling error? Let's try it again. Okay, the error message from before has now stopped showing. So it's exactly as intended. Okay, command buffers.
In Vulkan, we are not able to execute commands directly with function calls. We are first required to record them to a command buffer, and then submit the buffer to a device queue to be executed. While this may seem a bit tedious, it has significant advantages over older graphics APIs. Command buffers allow a sequence of commands to be recorded once and then reused for multiple frames. This is opposed to APIs like OpenGL, where draw commands would need to be repeated every frame. For now, we're going to record the command buffers once at program initialization, and then reuse them for each frame. Another option would be to re-record a command buffer every frame, which I cover a few videos from now. Command buffers have a life cycle described by this state diagram. When a command buffer is submitted to the device queue, it enters
Oh, what is this graphic? Man.
ending state.
Initial begin recording, it can be reset or made invalid. Okay, makes sense. When you end, it becomes executable, or it can go back to invalid, or you can reset it. Okay. Then executable submission completion. Okay. So you ask to make a frame, it computes, it sends it back, and then it loops, keeps sending a frame. Then runtime submit can go to invalid and then
It
reset.
is invalid to resubmit a command buffer
Okay.
that is already in the pending state.
Not too
It
bad.
needs to first complete before being resubmitted. The swap chain class provided first complete
It
before
does it hit. Submit
resubmitted.
multiple
The
times.
swap chain class provided limits us to submitting at most 2 command buffers to the device's graphics queue at once. After 2 command buffers have been submitted, the device's graphics queue at once. After 2 command buffers have been submitted, the CPU will block on the next call to the acquire next image function. When the GPU has finished executing one of the command buffers, it will signal the CPU to carry on. Therefore, it is possible to get away with using only 2 command buffers, even when there are more than 2 frame buffers. But when recording a start render pass command, we must specify the target output frame buffer. So in the case we have 2 commands but 3 frame buffers, we need to re-record a command buffer every frame. So at least for now, it is simpler to use a one-to-one relationship. Next, let's implement our create command buffers function.
I was kind of lost on that, but we'll see, we'll figure things out.
So let's start by resizing our command buffer's vector to be the same size as the swap chain image count.
Let's see, command buffer, not resize. Image count. And vk command buffer allocate info. Info.
Buffer allocate info, called alloc info. Make sure not to
curly brackets. Yeah.
to 0 initialize the struct with trailing braces. Now, just like with the other Vulkan structs, set the S-type member equal to vk structure type command buffer allocate info. Then the level to vk command buffer primary. There are 2 types of command buffers, primary and secondary. Primary command buffers can be submitted to a queue for execution, but cannot be called by other command buffers, while secondary command buffers cannot be submitted, but can be called by other command buffers. We will cover secondary command buffers in a future video. Be called by buffer allocate info. Info, called alloc info. Make sure not to forget to 0 initialize the struct with trailing braces. Now, just like with the other Vulkan structs, set the S-type member equal to vk structure type command buffer allocate info. Then the level to vk command buffer primary. There are 2 types of command buffers, primary and secondary. Primary command buffers can be submitted to a queue for execution, but cannot be called by other command buffers, while secondary command buffers cannot be submitted, but can be called by other command buffers.
I'm guessing the secondary one is just like for references. Not sure.
We will cover secondary command buffers in a future video. Next.
Yeah, whenever it goes over, I'll figure it out. For now, let's do this. Looking for, let's copy paste. That's okay. Get command pool, buffer count. And then this is just to check if everything ran successfully.
Member to equal device.get command pool. In the device class, we have already created a command pool when our device was first initialized. Command pools are opaque objects that command buffer memory is allocated from. An application may need to create and destroy command buffers frequently, so to reduce the cost of resource creation, Vulkan has us allocate and free command buffers from command pools. This way, the most expensive step of acquiring memory can be done once and then reused as buffers are created and destroyed. Finally, set the command buffer count variable to the size of our command buffer's vector. This expects a uint32 type, so static cast uint32
device, I'm looking for command buffer data.
Check that this is not equal to. The next step is we need to record our draw commands to each buffer. So in a for loop, int I equals 0, I is less than command buffers dot size.
For and caret for and I equals 0. Command buffer dot size I plus plus. There we go.
Then in an if statement, call the function vkBegin command buffer, with the command buffer at index
Begin info
I as the first argument and a pointer to the begin info as the second. Check that this is not equal to vk success, otherwise throw an error that our command buffer failed to begin recording. So the first another struct. It's called render path. Next, we need to set the render.
only of these two have to keep setting up. Make a command buffer begin info. Begin info command buffer begin info. If we can begin command buffer command buffer no. This is not command buffer, it's command buffers. Function shift F6. Yeah, command buffers. Amazon begin not equal to VK success. Yesterday failed to begin recording command buffers. Okay.
Which we have already one set up for us by the swap chain. So render pass is equal to swap chain dot get render pass. Next, we need to say which frame buffer.
Yeah. VK render pass begin render pass begin info. Render pass info. Render pass info as type. On the VK structure type render pass begin info. Wonder what the other options are that we keep having to set this up. Feel like it should be automatic if they are in fact all the same.
This render pass is right in. So render pass info dot frame buffer is equal to swap chain dot get frame buffer at index I. Now we need to set
Get frame buffer. Render pass info frame buffer equals only swap chain dot get frame buffer. Save.
this defines the area where the shader loads and stores will take place. So set renderPassInfo.renderArea.offset equal to 0, 0. Then renderPassInfo.renderArea.extent equal to swapchain.getSwapChainExtent. Make sure to use the swapchain extent here and not the window extent, because as mentioned before, for high density displays, the swapchain extent may actually be larger than our windows.
Is added an array slash include array. Render pass info not render area offset and render pass render area dot extent or always swap chain get swap chain extent. This is aggregate initialization of type. I have no idea what's happening there. Leave it.
Next, we need to set the clear values. This corresponds to what we want the initial values of our frame buffer attachments to be cleared to. So first, at the top of the file, include array. Then std array vk clear value with size 2 closing bracket called clear values. Then at clear value index 0 dot color, set this equal to
And what is this?
windows. Next, we need to set the clear values. This corresponds to what we want the initial values of our frame buffer attachments to be cleared to. So first, at the top of the file, include
Okay,
array.
if I just setting the default empty values for the frame buffer.
Then std array vk clear value with size 2 closing bracket called clear values. Then at clear value index 0 dot color, set this equal to an RGBA value of your choosing. Then at clear values index 1, set the depth stencil clear value to 1, 0. Remember that for the depth
Okay. Clear std array vk clear value. So clear values 0, 0 dot color equals 0.1 and 1f comma dot 0 then clear values 1 dot that stencil 1 comma 0. Okay. 0 0
buffer, the farthest away value is 1 and the closest is 0. Don't worry about the stencil for now. So one thing that you may find confusing is why we are saying the clear value 0 dot color, but not clear value 0 dot depth stencil. And that's just because if you remember in our render pass, we structured our attachments so that index 0 is the color attachment and index 1 is the depth attachment. Now let's provide our render pass info with our clear values info. So render pass info dot clear value count equals static cast uint32 type clear values dot size.
render pass info dot clear value count equals static cast uint32 clear value size. Okay.
And render pass info dot p clear values equals clear values dot data. That's it for our render pass info. So let's record to our command buffer to begin this render pass. We do this with the function vk command begin render pass. This first
render pass dot p clear values dot data.
command buffer we are recording to, so command buffers at index I. Next, pass in our render pass info using a pointer. And for the third argument, use vk subpass contents inline. The vk subpass contents argument signals that the subsequent render pass commands will be directly embedded in the primary command buffer itself, and that no secondary command buffers will be used. The alternative is to use vk subpass contents secondary command buffers, signaling that render pass commands will be executed from secondary command buffers. This means there is no mixing allowed. We cannot have a render pass that uses both inline commands and secondary command buffers at the same time. The first thing we need to do in our render pass is bind a pipeline. Jump to your pipeline header and add a
What's else? Is VK command again render pass command buffers I and render pass for and VK subpass contents in there. Yeah. Save.
Our render pass is bind a pipeline. Jump to your pipeline header and add a public function void bind vk command buffer command buffer. Copy the function signature and paste it into your pipeline implementation file. Add the class scope command buffer command buffer.
Where did I go?
Is bind a pipeline. Jump to your pipeline header and
Pipeline header. New window. And we close class. Okay.
Void bind.
Okay, it's adding it here.
vk command buffer command buffer. Copy the function signature and paste it into your pipeline implementation file.
Void bind vk command buffer command.
Scope before the function name, and in this function call vk command
and is here. Yeah. Only pipeline bind. There we go.
with the first command being the command buffer, then vk pipe
VK command graphics bind point. Okay.
The vk pipeline bind point graphics option signals that this is a graphics pipeline. The other types of pipelines are compute pipelines and ray tracing pipelines. We don't need any checks validating the graphics pipeline before binding, because it must have been properly created at initialization. Back in first app, call this function on our pipeline in the graphics pipeline before binding, because it must
Yeah, check if it's null. If graphics pipeline equal to null pointer.
properly created at initialization. Back in first app, call this function on pipeline. So lve arrow bind command buffer at index I.
This is in the first app CPP. All the pipeline bind command buffers I.
Then use vk command draw with command buffer at index I, then
VK command Okay, okay, draw buffers 310, yeah.
To draw multiple copies of the same being
Okay,
used for rendering particle systems. We'll cover this in the future. And then 0, 0, because we aren't using any offsets into our data. We actually aren't even providing any data right now, because if you remember way back when we set up our vertex shader, we actually hard-coded our vertices directly into the shader itself. And that's it for our commands. To finish recording, first end the render pass with vk command end render pass, command buffer at index I, and then in an if statement, vk end command buffer,
save, yeah.
we actually aren't even providing any data right now, because if you remember way back when we set up our vertex shader, we actually hard-coded our vertices directly into the shader itself. And that's it for our commands. To finish recording, first end the render pass with vk command end render pass, command buffer at index I,
Okay, and render pass. Okay, and render pass. Buffers.
vk end command buffer at index I, not equal to vk success. In which case we throw std runtime error fail to record command buffer. So these runtime errors are mostly for debugging purposes. For a production application, we'll eventually have to handle them more robustly. So the last thing to do,
Yeah, that's an if record vk command and render pass. Buffers are not equal to vk success through std runtime error failed to enter code. What is this? Might copy paste this. Let's end command buffer. Okay, and command hit command just and command buffer. Command buffer is I. Yeah, cool.
the draw frame function. First declare a uint32 type local variable called image index. Then on
And and 32 the image index auto result equals LV swap chain y and next switch.
this function fetches the index of the frame we should
image.
Optimal KHR. For now, we will just throw a runtime error that we failed to acquire the next swap chain image. But in the future, we will need to handle this situation because it can occur when our window is resized. Next, set result equal to swapchain.submit command.
So if result not equal to vk success, and then result not equal to vk suboptimal KHR. Through std runtime error failed to swap chain image.
The first argument being a pointer to command.
Yeah, almost done with this one. Cool.
Pointer to the image index. So what this function does is it will submit the provided command buffer to our device graphics queue while handling CPU and GPU synchronization. The command buffer will then be executed, and then the swap chain will present the associated color attachment image view to the display at the appropriate time based on the present mode selected. Finally, let's also check that if the result is not equal to VK success, in which case we will throw a runtime error.
Result equals the swap chain dot submit command buffer and command buffers image index and image index. If result not equal to VK success, to std runtime error fail to submit fail to present swap chain buffer. Swap chain image.
Then scroll up and in our game loop, just below poll events, add a call to the drawFrame function. So
Draw frame. 1 second.
in previous tutorials, in Vulkan, we are not able to
Just have to lock that up.
that something's not quite right. At the appropriate time based on then scroll up and in our game loop, just below poll events, add a call to the drawFrame function. So it's the moment of truth. It's time to build and run our code. If everything has been done correctly,
Okay, that stencil. Let's run first up CPP.
compiler errors or validation layer messages, and you should be able to figure it out. When you close
Control off. That
You will likely be bombarded by validation layer messages. This is to be expected and is because it's possible that a command buffer was being executed at the same time our application tried to close. A really easy fix for this is that in our run function, as the last line, add vk-device
we create a device. Wait,
device.device. By calling this function, the CPU will block until
kind of.
you may have noticed is that even though we never free the command buffers, we do not have any validation messages telling us they were not properly cleaned up. And this is because when our device is deleted, so is the command pool, and any buffers allocated from that pool will automatically be destroyed as well. So if you open up your
Okay, let's run it. Okay, nice, we have a triangle. So much effort just to do this. And even then, you can still see it has like anti-aliasing, all the like jagged edges. Might be fine on like a higher res, but for now, this is good enough.
here we can
I'm getting bombarded
change
with
the color of our
these.
triangle. For example, by changing the 0 to 1, we should now have a yellow triangle. Build and run your code, and then safely clean up all resources.
Wait, device idle. Okay, I think it's because roll. Let's see if I close from let me use the Vulkan window open successfully. These signal semaphores. I'm guessing it's because of the stuff I did for the device settings. Let me check. Change file device. Let me snapshot. Show of change. Let me just do this with the GitHub app. GitHub desktop. The devices. Stash change. Oh, let's copy paste this. Can copy paste this, copy discard changes. Build. Let's hit play. I'm still getting the semaphore stuff. Let's name this, and we let's see. We're still getting the same. Getting these semaphore things. Let's see. Affects us to passing a reference out of the initials. So control F semaphore. Says P signal semaphore. These aren't errors. Let me just Google search it first. Oh yeah, I finally changed to Ecosia on Edge. So now the only thing that uses Google is Chrome. And that's just like my default browser in case I need to do something with like credit cards or anything like super important where I don't want any glitches breaking things. Currently, the value of timelines info is increasing. Actually, wait. So I just needed to use of increment it now. Where I was going. I have no idea what a semaphore even is. Semaphore. System of sending messages. See, Vulkan. Okay, semaphore 3 or a synchronization primitive that can be used to insert a dependency between a queue or between a queue operation. Okay.
Knowing that they are no longer in use. One thing you may have noticed is that even though we never free the command buffers, we do not have any validation messages telling us they were not properly cleaned up. If you open up your fragment shader file, here we should now have a yellow triangle. Build and run code, and the triangle is still red. Well, this is actually a very common mistake. We forgot to recompile our shader code. Whenever you update a shader file, it needs to be recompiled. So you might want to set up an automatic build step to compile your shaders. How you do this will differ based on what development environment you are using. If you're unsure how to do this, a good place to start would be by Googling your IDE followed by custom build step. If you're using a makefile, I provided an updated version in the description below. What this basically does is searches for all vertex shader and fragment shader source files in my shaders directory. Note that this is a relative path. Then I do a pattern substitution, appending the SPV file extension to each source file, and I set those as a dependency for my application.
Let's see, CMake files, status.
Then have an added build rule that each SPV file depends on itself without the SPV extension, and can be built using GLSLC. This way, whenever the shader code is modified, a new SPV file will be generated automatically. So now if I build and run, my fragment shader will automatically be recompiled, and my triangle has changed from red to yellow as expected.
Maybe Unsurf can handle this. Let's see. Add a step to recompile all the word and flag shaders to SPV using GLSLC. Let's see what it comes up with. Yeah, that was so much more work. Patch dependencies and program GLSL. I'll just check if this part works. Let's build it. Let's see. Okay. That seems to have worked. Function to compile shaders. Get compile shader. Okay. Shadow handling. Add custom target. Let's rebuild. Let's see how it goes. Okay, let's go to the shadow. And make this one. No extension. Did not rebuild it. So rebuild it this way. And upgrade. Nope. Let's save and check. No. Semi-closed. Semi-current source directory. Find and compile only. Can I just use this in the notes? On the device? No. Stop, yes. Hmm. Let's try this. File to open file, but like 2 dots.
So now that we've
Okay, 2 dots seem to work. Okay, let me check the files. Game making, Vulkan stuff, Vulkan learning. 64 debug. Let's see if let's see. Control F, shadow. Where's the word? And the triangle could make us prefer. Except problem with my shape. Scenic to compile GLSL shadows. After searching a bit, I deleted look like this. How to compile shaders with CMake. Okay, seems like my earbuds ran out. Testing. Yeah, testing.
You've drawn a triangle, it's a good time.
Okay, let's see. Let me for now just run the compile back. Okay, let's remove all of the GLSL stuff. Okay, it's reading it from the but no, other compile. Let's just finish the
Step
rest
back
of
and
this.
review the role of each component and the relationships between them. In the next video, we will remove the hard-coded data from our vertex shader, and thanks for watching. Please
Okay, control F, compile. Okay, that is also stuck in the same place. Stuff try of compiling every shade as a will step. Try to figure out if it's modified, and if it is, compile it. Everything compiles fine. Okay, this guy's getting the semaphore issue. I'm having the same issue, but I haven't seen any fix anywhere. So it's 5 replies. So hmm. don't like make files because of that. Then automatic shader, if shader was changed or something. Improve the build process. For now, I'll just stick to manually compiling it, I guess. Like right now, yeah. I'll just see. Add run the compile not that file during build. Add custom command. Add executable. Let's rebuild. Just to test it. And goes back to 0. Okay, that worked. And let's make this one. That did not. Add custom command. I done this like before. Hmm. Let's see. Extension is this command is not in code. Hmm. Let's say I know the custom build stuff. I don't use a real studio often. That fixes this problem. change it to CMake at some point.
Hello coders, so this isn't going to be the most exciting tutorial and it's kind of optional. This video is just going to so find the location you currently store this library and copy it to your external folder. Next we need to create a new file called cmakelists.txt and we put this at the top level of the project. This is the configure the path variables for your project. Unix example.cmake, which also
Okay, let's check these out. And that part is not required. Search your FW path. Add executable. Target compile. Build shaders. Okay. Okay, let's put this at the end. Let's see if it builds. Okay, let's try it. Let's run it again. I have no idea which part is the issue. Set any object, set minus w. Build shadows. I just think it's a spelling error. Hmm. Fine program. Okay, I'll just put the direct path here. Uh, GLS source files. That's all in the shadows. shadow. Let's try this. Nope. Generator. Is it getting made in the CMake build? Source testing. CMake files. CMake API. Hmm. I think for now the best is to just run this and then run this. How do I even know if it's building anything or not? As soon as JLSL validate executable. Vulkan SDK path bin. I guess I'll get to this when I reach there. For now, I'll just stick to what has been working. Can't wait. This one is still there. Isn't doing anything, but it was there. Let's try without it. Change it. Make this 0. Make this 1. No.
Paste bin links.
Here's in Visual Studio.
Some of this depends on which platform we are using. That's why we have all of these if statements and else checks and so on. I also specify the project source as an include directory because that's where our header files are located. And as a last step, we say to link the GLFW and Vulkan libraries to our project. So sorry I went through that kind of fast, but I found that these videos here were helpful for me, at least when getting started with CMake. So if you're looking to gain a deeper understanding of what's going on, I recommend checking them. It's all the vertex and fragment files in the shaders directory. And finally, each of these shader files will be built to their corresponding SPV file to be used within the engine. Okay, one notable change with how CMake works is that our executable will now be stored in a top-level folder called build, and should be executed only from that location. So when trying to locate resources, relative file paths should be specified as if we are located in the build directory. For example, to find a shader, we need to go one directory up from the build to get to the top level of the project, and then into the shaders directory to find a shader file. So we need to update the file path for each resource to do this. I'm going to open the pipeline implementation file and declare a new constant called engine dir equal to one directory up. So when executing the project from the build dir, this will be the top level of the project. I'll then have my refile function concatenate this directory to my file path and use this new value to locate my shader resources. And okay, now we need to do the same for loading models. I'll copy this definition here to paste into my model implementation file,
Hmm.
and then update the create model from file function to use the engineer plus file path.
Let's see if anyone else's random issues. Instead of a one folder also, including the shader folder. Hmm. I'll deal with this later. Let's end stream here today. We have finished 3 of these tutorials. We have a triangle that works. So let me just run it once more. Let's remove all of this. So, simple clean rebuild. That's it. Play. Okay, that's compiling properly. Okay, I'll see you all tomorrow. Yeah, bye.